we go.
Animations.
Hi.
Hello.
Hi, Gabe.
Hey.
How are you?
I'm doing all right. How are you?
I'm good. Episode 4.
Episode 4 and 5.
And 5.
And 5.
So for those watching on YouTube, we will do one episode now, and then we'll be one next week. Or if you're watching this later, I mean, there's another episode, so you can just watch it.
Everything's in the playlist. It's amazing.
Magic.
We got some cool stuff to do today.
Yes. So from the last 3 episodes, we've been kind of ramping up the difficulty, using only the 4 concepts that we have been learning before. And this is kind of ramping it back down, it's more introspection into what we can do with the concept that we know, and we're going to learn a new thing. For this episode, we're not going to use the game. We're going to start off fresh, and then in the next episode, we're going to apply the knowledge onto the game to make it better.
Sweet.
Better game.
Ready to go?
I'm ready to go.
Sweet. It's your time to shine.
My time to shine?
Your time to shine.
Hi, Gabe.
Best part of the presentation.
It should be, yeah.
Hello.
For those who listen to the Endgone podcast, yeah. This should be a t-shirt, right?
Oh, just put hi on it. It could be hi anybody.
Yeah.
It shouldn't just be hi Gabe.
Last week was tricky.
Yeah, it was.
It was a lot. And we went over a lot of code very fast. Yeah, like I said before, this week we're going to slow it down a little bit. You learn a few new tricks, but first, some practice.
Oh yeah,
practice is very important. So these are a few questions, and the question is always: we have an if statement, then there's some value here. It's true, and the question is: will we go into the block? Will the if allow us to pass through? And in this case, yes, because it's the value true, and that is what if is looking for. If doesn't look at the whole expression, it will always break it down into one single value, and then look at that one single value, and then ask the question, is it true or false? If it's true, we will go into the code, into the block, whatever the block is. Okay. So here, we have a variable called year. It is the year 2018, unless you're watching this in the future.
Ooh, snap.
And what is the question?
If the year is greater than 2000.
Okay.
Will the code inside run?
Will it?
Yes.
Yes.
Because the year is 2018.
It is 2018. Also, it's maybe odd if you were watching this in the past, but let's not get into that. So what it does is we have the variable year. The year has now the value 2018. So what the computer is doing is it's doing this. Is 2018 bigger than 2000? That is true. So we will go inside the code block. Okay, good. Next one. We have year 2018. We have month 11. And now we're asking 2 questions.
Is year greater than 2000? And is month greater than 0?
Mm-hmm.
It's still true.
It is still true. What it will do is it will replace the values. Year is now 2018 instead of the variable year, because that's the value. Month is now 11, because we only want to deal with numbers, and the variables are just an idea on top of the number, or storage for it. So these are then true and true. And like we learned last time, true and true is true.
Yes!
Indeed.
Got it.
Next one. Oh. So yeah, here we go. Yeah, next one. So year is 2018. Month is still 11.
This is false.
This is false.
Because the month is equal to 11, but it's not greater than 11.
Exactly. So again, year is 2018, bigger than 2000. That is true. But the second one is 11 bigger than 11. That is not true. We have true and false, which is false. So it's false, and we will not go inside. Good. And then the last one.
Oh my God.
So we have year still, 2018. And we want to ask the question, and this is Boolean. Boolean is just like int. Int stores numbers. Boolean stores true and false. So it's all about what do we store.
This is false.
You say this is false, okay?
I think it's false.
Okay.
Because 2018 is greater than 1989. But 2018 is greater than 2000, so it doesn't fulfill the second half.
Correct. So 2018 bigger than 1989. Correct.
Quick math.
Quick math. Greater than. Maybe not greater than, bigger than, maybe.
Bigger than.
And 2018 is 2000 bigger than 2018. That is not correct. So again, it's true and false, which means that the variable is storing the value false. It is not storing this. Before the variable stores that value, it does this calculation.
And is 90s is just the name of the...
Yes.
That does not actually like a processing word. It's just what you've called it.
Correct. Yeah. So that's the variable name. Boolean is the type. And the same year is a variable name. Int is the type. And then
Boolean always asks...
Boolean can only store true and
True
false.
And false. Yeah, okay,
It's just about storage. It's not asking any questions. It's just a container that holds data. And the only data that Boolean can have is true and false. And the only data int can have is just a whole number. So again, even if there is a complex expression on the right-hand side, we still have to break it down into a value that Boolean can store, which is either true or false. In this case, it is. Which then means is 90s is a variable, contains the word false, and not the word false, that contains the value false. If is then false. So again, that is false, and the code will not run because it's only for 90s kids or something.
Yes, that's me.
Fun. So,
Typing some types.
So that was good practice. Just messing around. It doesn't have to make much sense. It doesn't have to be a game. It doesn't have to be anything big. Just playing around with what happens if type of questions. And they can be very small and just you can mess around. So, like we talked about in the previous slides, Boolean is a type that stores true and false. Int or integer is a type that stores numbers. Cool. So here we have, again, int and year. What is, like, if you just look at this, there is some meaning that you are applying to this, right?
Yeah, you're saying that every time you have the word year, it's 2018.
Mm-hmm.
It stores that value.
Correct. And if you would have some code afterwards, right, that uses year, you would imagine it has something to do with years, dates, or time, or whatever. But the computer doesn't know that.
Is this why we thought all computers were going to explode in the year 2000?
No, that's another thing.
Damn it.
We can go into that later. That was a whole thing, but yeah.
That was funny.
So if you look at this, int year 2018, the computer knows about int. It knows that, hey, yeah, he wants to store numbers. So there's no ambiguity there. Int is a number. 2018 is a number. So the computer's like, yeah, that's cool. What do you want to call it? What the name of it actually is, it doesn't care. Because the computer or the compiler does not read your variable names. They are for you alone. But since you gave it the name year, you added some context to it, right? And I said, in the following code, if someone says year, you would think that has to do with year or date, right? If I do number of episodes, it's 4 plus 1, because this is the fourth and we're recording the second one in a bit. Again, there's meaning here. We're going to, first of all, calculate that value. That value is going to be 5. And again, it has the name episodes in it. And that is some context for us. But is there, in other sense, any differences between year and episodes?
Just the value that they store.
Yeah. Could I store 2018 in episodes?
Yeah, it might confuse you a little bit later, but you could.
Yeah, could.
You could store whatever you want in there.
Yeah. Again, it's just a container of values. But it's us, as the programmers, that apply that meaning. But the computer is not going to stop us. We can be idiots if we wanted to. And again, if we talk about
where you have like variables that are like capital I's and lowercase i's. So it's just, or capital I's and lowercase L's. You just mix and match. So it's just really confusing with what the name is.
You could.
It just looks like a line of bars.
You could do that. Again, if you have a variable called height, so 100, would you imagine is meters?
80, that's really tall.
Yeah. No, sorry, centimeters.
100 meter. I imagine a person, so I was like 100 meter person. Whoa.
But yeah, look at that. You imagine the person.
Yeah.
Because you're looking at 185.
Yeah. Yeah, exactly.
Again, the computer doesn't care. But you immediately added meaning to that. And that matters. So if I do this.
Int huh?
Like, what is that?
Yeah.
If I add together year, episodes, and height.
You have some weird mix of those numbers, but you have a value.
Yeah, it's still a number.
Yeah.
But what is the meaning behind that number?
Something.
What do you get?
I don't know what equation or what value holds year, episode number, and your height, but something does.
Yeah, like someone asking you a question like, so what year is it now? Plus, what many episodes have you gotten, and how tall are you, and what's that value? Like, that value has no value if you think of it that way. So we can do this. So the first three make sense in their own context. The last one doesn't make sense in any context, I think. I think I'm safe to say, or unless if someone finds a meaning for it.
There's some correlation between the episodes we've done and the height of us.
Yeah.
We'll only make it to episode 6 because we're only 185 centimeters.
Exactly. So
we're going to go way past episode 6. Just saying.
Yeah, but there's the computer or the compiler allows us to do this because it allows us total freedom, and there's a trust that that's what we wanted, and that's the power of the programming. Is it's not only creating values and then manipulating them, it also has to do with the meaning behind it. But here, there's no safety net, and that is a problem because we like safety, and it's also I don't want to have to worry about making mistakes. I would rather create meaning in the code, if that would be possible. So, context matters. A year is a count, and it can only be incremented at a certain point when the year is over. And when you subtract to the year, so if you say year equals some value, 1, that 1 is also a year. It's a whole year.
Just thinking in my head how you actually tell the computer's time to go to 2019 when the clock strikes 2019 and how many days that is.
Oh, that is time and time zones are an incredibly complex subject matter. We might look at that in the future, but for now, no.
Keep it simple.
Again, height has some value. It's in centimeters in this case, and adding year to height makes no sense. Even both are numbers. So even though we're just dealing with numbers in our head, we're adding a lot of context and meaning to those numbers. That's the point here. Yeah, but the computer doesn't see that.
It doesn't care.
The computer doesn't read our code. It takes our code and bunches it up. And in some cases, for example, in C++, the code that we write is not the code that runs on the computer. Not at all. There can be pages and pages of code that end up as the number 4. Because the computer, before we even run the code, it figures out what we are doing. And then says, I can actually simplify this for you. And this is actually some other value.
Smart.
People who make compilers are very smart. So if we could represent that context directly in code, then we understand what's going on. And then the computer also understands what's going on. Or it can warn us if it's being silly. As before, it couldn't. So let's back up a little bit. So Gabe, cars are complex.
Yep. I watch a lot of Formula 1.
You do?
Yeah. So I know cars are pretty complicated.
Those cars are very complicated.
Especially when you try to make them go super fast.
Exactly. It's funny, like let's go as fast as possible within the boundary of rules. It's okay. So here's a car.
Yep, that's a car. Did
Stock-
you draw that?
No,
Okay.
free stock photos.
Yeah, I was gonna be like, damn, that's impressive.
Okay. What is this?
It's a wheel. It's the steering wheel. Not a
Right.
wheel. It's a steering wheel.
Steering wheel. What's this?
That's the pedal. I don't know if that's the gas or the brake, but it's one of them.
It's one of those pedals. What's this?
It's your shift stick.
Transmission.
Stick thing.
Yeah, the thing, right?
Yeah.
The thing.
Shifting gears stick.
Yeah.
Make car go forward or backwards stick.
You're actually going ahead
Oh, it's
of
not-
the slides,
Uh-oh.
but
I cheated. I
it's
haven't
fine.
seen the slides.
He hasn't seen the slides. So turning the steering wheel will make the front tires rotate. Correct.
Hopefully just the front. It'd
Just
be
the
really
front.
awkward if it's
Mhm.
the back.
Pushing the gas pedal will inject gas into the engine.
Make go forward.
Pushing the brake will clamp the brake discs together to cause increased friction on the rotor.
Make go stop.
You're basically you're doing the slides in my head. It's
Oh,
hilarious.
damn it.
It's funny. And the gearbox regulates torque transfer from the engine to the transmission. In a manual transmission, the flywheel is attached to the engine crankshaft and spins along with it. The clutch disc in between the pressure plate and the flywheel is held against the flywheel and the pressure from the pressure plate. This is no.
It's just a lot of information.
Yeah. This is no.
No.
Wheel turn,
Wheel turn.
gas go,
Yes.
Brake
I got
stop.
it.
and gearbox. No, it's too much.
Just go automatic.
Just go automatic. The thing here is a car, the wheel, the gas, the brake, and the gearbox is what we call an interface. You're sitting in a car, you have a wheel in front of you. If the car is running, etc., when you turn the wheel, it turns the car. If you press the gas pedal, it will go forwards. If you press the brake, the car will stop. And the gearbox, no, let's not go into that. But what actually happens when you press the gas pedal, do you know? Like, do you know the intricate details of what happens when you press the gas pedal?
You release something into the engine and then it shoots and makes fire and it goes forward.
Yeah, but
It
is
does
it
something with pressures and
probably, yeah.
Yeah.
Is it the same in every car?
no. We have electric cars.
We have electric cars, that's
Yeah.
correct.
I don't even know how those work. It's
Mhm.
magic.
Do you care how it works in cars? When you're driving regularly using a car?
No. I just know that pressing gas makes go.
Make go,
Make
gas go, and if it doesn't, the car is broken.
Yep.
So that is an interface where from you or your perspective as a user, you just press the gas pedal and the car will go. What actually technically is happening, that's why I had this thing, doesn't matter. And even this thing, pushing the brake will clamp the brake discs together to cause an increased friction on the rotor.
No, just make stop.
Yeah. The rotor, like, okay, that's like the plate and attached to the wheel and all that. Increased friction, is that in all cars? Probably, but I can imagine some other systems. And this is, no. So here we have an interface. And we can do the same thing in code. We can create an object, create a thing, and then give it an interface. So when someone uses that object and then presses and pushes and turns the things, the object will do what we designed it to do, right? So let's go to class.
I'm in class.
Oh, okay. But let's talk about a class.
Okay.
And this can be represented by an idea called a class in programming. In other languages, it has different ideas and meanings, but I'm going to simplify this a lot right now. For those who know a little bit more about this, might raise their hands, but I am simplifying a lot for a reason. A class groups together variables and functions. So again, even if we're learning a new idea here, it is still the same core concepts. It's a grouping of variables and functions. It's a grouping in a very specific way, and we'll practice that in a bit. But it is still a grouping of it. So it's nothing more than that. But with that idea, we can start to represent what variables belong together, and most importantly, in what context they can be used. So you can imagine if you create a car in a video game, that there would be some way to call a function called gas. And then that would mean that the car will go forwards. A function called stop or brake, which will make the car brake. And classes are much more about design. Like with the interface of a car, someone designed that. The technical aspects are up to the engineers how to do that.
So are you a designer too?
In a way, yeah. Programming is design as well.
Not bad.
It's not in the classical like art sense, not in that classical sense, but it is still design, because you have to write the code and you have to then think of the users of that bit of code and if they can use it in a way that makes sense. If it is an intuitive interface like a car, which I like as an example.
It's a good example.
Yeah. And again, to make clear, we're still only using our 4 original concepts: variables, conditions, functions, and abstractions. And a class is an abstraction of variables and functions. It groups them together, creates an interface that makes sense and is usable. Yeah, what I said. A class is an abstraction of variables and functions. So let's say we wanted to create a variable called health. We want to store or manipulate a number. Health could be health in a video game or whatever.
Please don't make it 0.
I won't assign a number to it. Let's just imagine there is a variable called health. It would have some value later on. Okay. If I wanted to only do that, as in create the variable under certain conditions, what usually is done is you create a scope. You put the curly braces around the thing you want to scope. This is called scoping. So that means that anything within the scope knows about each other, and anything outside of the scope doesn't know about the thing in the scope. So if I have a variable outside of the scope, above it or below it, it doesn't know about health, but health knows about it. You can think of it like you're standing taller than the others and they can't see you.
Like two-way mirrors.
Could be, yeah. If I would like to ask a question and then create a variable health, I would just add if on top of it. You can see it's the same thing. It's a scoping, but it's a conditional scoping.
So this is asking, so if damage is greater than 0,
then we're going to do something about the health.
Then health is going to be... Is that when you say health is going to be called and like...
We're just creating a bucket called health that will store numbers.
Okay, so this is just saying if... We ask the question first, like if the damage is greater than 0, then do whatever is in the curly brackets.
Correct.
Oh, okay. Which could return something.
It doesn't return, but functions do return things.
Okay.
Yeah. But yeah, it is correct that in this case, we're asking the question, is damage more than 0? If it is, we go into the curly braces, we create the variable health, and we might do more code later on.
Yeah.
But that's the important...
But for now, it's just...
Yeah, it just doesn't do anything.
It's just health.
It would, if this was actually the full code, it would say damage more than 0. Let's create the variable health and then just exit and then continue on. It doesn't do anything. But I'm imagining more happening. So, but if I have a function that has something to do with health, like do damage, in this case it doesn't return anything. It's a void. So I have a function called do damage. Someone sends in damage as a value, and then we create the health variable and then more code probably below. But you see, if I go back, it's all the same. It's conditional scoping, function scoping, and then just no scoping. Got that?
No scoping. Is this 360 no scoping?
Exactly. It's just regular scope. In processing, you can't do this. just an empty scope. It doesn't seem to work, but in other languages you can do this. So you always have to put something with the scope. So what is a class then? Well, it's just another scope. Here I create a class called player. And since we talked about before, a class is a grouping of variables and functions, right? So what do we want to group in this class? Well, only the health. This actually...
So that's only saying like the class is the player.
Mm-hmm.
It's just health.
Yeah. So the object that we would like to create is called player. And the data in the object, in this case, is only health.
It's just health.
Yeah.
Just whatever health may be.
Yeah.
Because health could have a value somewhere else in the code, and it'd be calling that value.
Yeah, I can set this value somewhere else in the code.
Yeah. So if it was 100, essentially player would be 100.
Yeah. Or player health would be 100. And you'll see in a bit how we use this. It's a bit tricky how we need to set up the variables and how we use them.
I'm thinking of it in like a game sense. Like if you have player and your character is player, you start at health 100. So you've told somewhere else in the code that health is 100.
Correct.
But then you could just continue to put whatever health is into other variables.
Oh yeah.
That would be like, now you take one punch to the face, so that's health minus 10 or something like that.
Yeah. You could also say, I created the player. Now I have a player in my game. A player only has health in this case. Not a very complex game, but okay. I set the health to 100. All right. So that means that the health inside of player is 100, because it's the variable health that is stored inside player is 100. And then somewhere else, I can just create a regular variable, standalone, like we've always done before, int, whatever. And that variable can take the value of that health. There's nothing magical about this. This is just a grouping. This is just a container for variables. And I can add another one.
Oh, snap.
So now we have health and level. So a player has health and a player has level. And again, if I would create the player and then set the values of health and level, if I then do damage to enemies and blah, 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 and level up enough, get enough XP, I'm then maybe allowed to increase the number of level. But again, that is stored within player. And another important thing is what we call class, or what we would call player in this case, we are creating a type. Like int is a type, Boolean is a type, and those types are created by the language. But we can make our own types. And our own types are classes in this language. In other languages, it's maybe called something else. But in processing and many other languages, they're called classes or sometimes structures. And like with int, I can create multiple variables that store int. I can create an int something and an int something, just like we saw before. In the same way, I can create a player here and a player there and a player whatever. And those are variables. And those are just as independent from other variables as int. So I can create a player called Oli, and it has health of 100 and a level of 1. Then I can create a player called Gabe, and he has a health of 2000 and level 99.
Oh, snap. Come at me.
Yeah. And those are not the same variable, and those are not, don't contain the same values. Absolutely separate.
So Fei Lao is her own class.
Yeah, you can think of it that way.
Fei Lao. One leg.
Or Boolean has both legs.
No.
False.
Well, no, she has both legs.
Okay.
One is damage.
Okay. So, yeah, and we could store a Boolean in a class. We can store an int in a class. We can store any type in a class. We can even store other classes in a class.
Oh, snap. Classception.
Yeah.
That's not... No. That's not the way you should use Inception.
No. When I say we can store any type in a class, I mean any. And the player there is also when I say we can store any type in a class, we can store absolutely any type. And if we make our own types, we can also then store them in other classes. And we will see that later
So we
on.
can make a whole class just called health.
We could make a class called health, and then a
much
player.
More complicated thing.
Yeah, it has like functions about increasing the health and decreasing the health, and then the player has not an int health, but has a type called health. So as I said before, a class is a grouping of variables and functions. We have seen the variables, but we haven't seen the functions. And as simply as putting the variables there, I'm going to shrink the font a little bit.
Ooh. We got some more stuff coming in here.
You just put the function. You can see from the definition, you have a void function. It doesn't return anything. Great. It has a name. Okay. It has the braces like before. Okay. It's no different from when it's outside of the class. So when I say a class is a grouping of variables or functions, I mean that. It's just here.
So when you say doesn't return anything, so I get a little bit confused whenever you say that, and maybe I should have asked this earlier.
Mm-hmm.
What exactly do you mean by? So I know void doesn't return anything, but when I think of return, it's still level equals level plus 1. So that is a value.
Yeah. So if we would have, let's say you have a function that returns an int. So it would be int level up. You would have to do whatever code is in there. Level is equal level plus 1. And then you would have to say return level.
Okay.
Because that then means you can say int new level is equal to level up. So
what this is saying, void level up is whatever level equals level plus 1 is.
No. Void is no value.
Yeah.
So you couldn't. We're gonna go. I'll show you this in a bit.
Okay.
Yeah.
But just because it's just in my head, so I understand, and maybe there are other people, but it's just mostly my curiosity. When you say doesn't return a value, immediately I go, so why is that necessary for us to say? If it's not returning anything, why is it necessary?
To let the computer know that it's not going to expect any value when you call it, and you can't assign a variable to the value this is going to return.
Okay.
And I'll show you that in a bit.
Okay.
But here, there's a from the code before. You remember that anytime you wanted to call a function, you would have to keep putting arguments in. You have to say like, oh, we want to send in the x and the y and the box and the width and the height, and it was a mess. Here you see that we're not sending anything in. So level up is an empty, but we can still say level. What do you think that is?
Your level?
Yeah, where is this variable created?
Level?
Yeah.
It's created above.
Yeah.
Right above.
Yeah, because it's in the scope. Like I said before about the scoping, the level variable doesn't know about what's inside of level up, but that's another scoping. Does my mouse work here? Yeah. So here's one scope.
Yeah.
And we create level. So level knows about health and knows about there's a function
called level. And then you created another scope.
Yes.
So inside the scope, it can talk to things outside of it, but everything outside can't talk to it inside of it.
Yeah.
Okay.
That was exactly it.
So in this case, if you want it to level, because I assume level up means you're going to level up.
Mm-hmm.
You're saying that then level is now level plus 1.
Yes.
If you have leveled up.
Yes.
Which will change the variable of level.
Yeah. Which is the variable that we store here. So we have in all the functions that are created in the class, we have direct access to all the variables we create here without having to send them in.
So basically this is saying that level up shouldn't return a value, but there's still stuff happening within that scope that needs to be taken into account for all the other variables.
Yeah. So when we call level up on whatever player we have, this code here will execute.
Yeah, but it won't return.
No. And it's the same way that if I have a car and I press the gas pedal, it will do a thing. it will go forwards. But there's stuff happening internally.
Yeah.
And that is this. This is the internals of what is ever happening when I level up or press the gas pedal or the brakes or whatever. Vroom. So let's practice creating classes and just see what happens. This is more an experimentation, and we'll create a few classes. We can even make this one here, and we can also look at the question you had about what void means in that sense. So let me switch over to. So for those who not know the tool we're using, it's called processing. We're using it on the website Open Processing, and on the front page we have this pretty thing, which is written in processing, by the way. This whole thing is written in processing.
Everything better be written in processing.
It's like, oh no, this is written with something else. You know what that's called?
What?
Eating your own dog food. Yeah, it's called dog fooding. Like, why would you create a tool that can do this if you're not then going to use the tool that does this?
This is true.
Why would you feed your dogs food you would not eat yourself? Yeah. And on this website, you can either like join or sign in and all that. But if you scroll a little bit, you don't even have to sign in. You just click here to create a sketch. And when you click that, I'm already logged in. I'm like a chef.
I'm gonna create a sketch. We're making it starting fresh.
We're starting fresh. Please remember that you have to click processing JS over here because we're using that language. This site supports 2 languages. And we don't need to do anything else. So we're starting fresh.
Doing real big text today.
Real big text. We're probably going to shrink it a little bit.
Yeah, you got some real big text. I'm going to go down to the W.
Yeah. Let's go to the split, I think.
To code.
Yeah. Let me do that.
Snap this to the left.
Oh, snap.
Beautiful.
Yours is not showing up. Let me see.
Apparently my OBS just closed. Mine will show up. There we go.
There we go. Simple. Okay. Let's tackle the question you had first before we go on. And I'm not going to run the code directly, but this is more of an exercise. If I create a variable called int, let's call it Gabe. It holds the value 5.
Nice.
So it's an integer called Gabe, holds the value 5. Great. If I create a function, let's call it massive. So it's a function called int. It's called massive, and then it doesn't take in anything. No arguments coming in. And then I have this. What this means is whatever I do in the code, there's something here, at the end of the function, it has to have a return.
Okay.
So let's say we have int something, or we could do this. Int division is 1. And then we say division is equal to, we have division 2.
Bam.
That's how you make division 2? No.
Done.
So first, division had the value of 1. Then we updated the value.
That is how you make division 2, though.
Correct. The variable.
It's not a lie.
The variable. So now we incremented it by 1, and then I return it.
Yeah.
So again, with the scoping, this variable only exists in this scope. We increment the value by whatever.
When you're saying return.
Return means then this. If I can take you out of the picture.
No.
I can say that a variable called game, or it could be called Gabe, or it could be called whatever. The naming doesn't matter. Let's call it game. Is equal to massive.
And that is returning the value of division.
Yes, because this function is basically an integer, but you have to compute what the integer is. So if I say here, just call it stuff, and I add stuff to whatever the number is, I can put 100 in here. So I call the function, I send to the number 100. Stuff is now then a variable which has the value 100. We create division, increment it by 1, and then return
division plus 100.
100. So it's 102. So this is in all regards an integer, but you have to compute the value before you can know whatever the integer is. So that's why we can assign it to a variable, because variables store just numbers. But in the same sense that we had to shrink down the if, in here we have to compute the value. So this in actuality will return 102. So this is the same as 102, but we have to do some work first. So, but if this was a void function, let's say it doesn't take in anything, you cannot return, because void is nothing. So here, I cannot do this, because this is an int, and this is a void. They're not the same type.
So
And
it doesn't know what to do.
Yeah, and it doesn't return anything. So there's no value to get out of the...
But regardless of the int game down below,
Mhm.
the void is still saying division 2 based on what's there.
No, because it was, if you go back to here,
Yeah.
it is the return that is the important bit. The return is the line that will turn the function into a number. All of this will be discarded at the end.
But when it's a void, it's still discarded? So what you had before was just...
It will be discarded, yes. That is a correct assumption. That if I do this, I create a variable called division, I increment it by 1, I exit the scope, and this thing is then destroyed because it only lives in this scope, and then it's gone.
But if it was within another scope and the value and something else had division before it, so if you had an int division,
You could capture it that way, yes, because it was in the previous scope, and this one knew about it. And what you're thinking about is this.
yeah, basically.
Yes.
Yes.
And that is the same thing we're doing with the level up, but you can't assign it because it has no return, and it returns a void where the value is void. So this doesn't work. And I think even if I do this, oh no, it doesn't actually. Let me do a quick. You have to write this guy before anything happens. It doesn't actually warn about it. That's not that great, but anyway, it should warn about.
Exposed.
Yeah, but what you then have to do is you have to do this. Because you cannot assign a variable to a void, but you can still call it.
But now you're just saying division is 2 and massive is 100.
There we go.
No, massive is nothing.
I sent in 100 into massive, but it didn't take in anything.
Yeah.
So
Just gone. It's nothing.
gone. So division is 1. If someone calls massive, division will be 1 higher. Here's massive. I called it. We can actually play with this a little bit. If I have the setup function here, let me do this so I can scroll in. So I can do print ln and division. It just prints the division. I want to...
Just prints it.
Yeah, just print the division. Let me... I forget to do it like this because I want to scroll up. Don't worry, I'll fix it in a bit. There. Like we learned from before, setup is only called once. So print will only be called once. If I call it here, what doesn't it want to call? Am I not naming it correctly? Void setup, yeah. What's going on here? This is odd. Let's not waste too much time in this, and I'll look at this later. But yeah, you're correct that this variable exists in this scope, which this scope then knows about because it's outside of it, and it can increment the number. So if someone calls massive, the number is 1 higher. But you can't get the value from here. Okay, so let's practice. Let's make a class.
Anything?
Let's... what should we create? Let's create a class called color. with a big C. And we want to store. So what do we store in color?
RGB values.
So that's then 3 variables, right?
Yes. So we need to do int R.
Let's call it red to be more descriptive.
Red, int blue, green.
There we go. Let me do.
Yours is much more zoomed in than mine.
Yeah.
It's like, why is mine so small? So I need to set this up.
Yeah.
Set up.
While you're setting this up, let me see if I can get the print thing working again. Sorry, I'm playing with this a little bit. It doesn't want to show the little window. That's very odd. Let's look at the reference. Maybe I'll be doing something wrong. It's called println. Here it is. Yeah, println. It's very peculiar. Do I have to put in text? Do I have to do it in draw?
I think we did it in draw last time. No? I remember it being... No. I don't remember. I have bad memory.
It's very odd. Anyway. Yeah, we don't have to set that up like that. So, here we have a class called color. It is storing 3 values. A red, a green, and a blue value. These are just 3 ints. And it would be the same as if we would do this.
Yeah. But we put them in a class called color now.
Yeah. With a grouping called color. And we need to then use that. We want to fill it up, put some values in it. So here, below, we can say color. I can just call it color 1. And then just a semicolon. Oh, sorry. No, it's then new color and then nothing. So this is a quirk of this language. When you create a variable from a class that you have created, you would do this as before, like we do with int, type it before, color 1, just the name of the variable, and it's equal to something. We're gonna evaluate it to something. But what we want to do is we want to create a new instance of this. We can think of this thing here as a blueprint to what we want to create. And this will create a copy of it, an instance of it. This then allows us to do this. And these are then 2 distinct colors. They're not the same color. So let's use that color. Let's do the thing before. So we do size is 800 by 600. And then background would not take in 000. What it would take in is just color 1 dot red. And that's how you access. So color 1 is the type color, which then is a grouping of the variables. So red is within color 1. There's a red within color 2, the variable. And to access the variable within the color, you do a dot. So you say color and then dot and then the name of the variable. That's how you access whatever it's grouping together. So let's do that for everyone. How would you think you would access the green one? Ooh, here it is. It apparently, if I zoom in too much, it appears. That's good.
Would it just be color? Do we want to put it in color 1 again?
Yeah, let's use color 1.
Color 1 dot green.
Yeah. That's green, and then Let me zoom out a bit more so you can see what I'm doing.
Color 1.blue.
Correct. Color 1.blue. So let's try that out. Let's hit play.
Oops. Ah.
All right. It's black.
But we haven't given them actual colors.
What was black?
0.
Yeah. So they have the value 0 in this case.
Yeah, we haven't actually told it what red, green, or blue is.
So in this case, it was defaulted to 0. So let's give them a value. And you can say color 1 dot red. And how would you think you do this? You do a small c on there in the beginning.
Oh.
This is a value and a variable just like any other.
Would it be brackets int?
Brackets are for function calls.
Oh man, I don't know. Oh, equals.
Yeah, it's just a variable like any other. So we can then say color 1 red is equal to 255.
I was way overcomplicating that.
Yeah, we hit play.
Bam.
Red. We can say color 1 dot green is equal to 255. We hit play. Yellow.
Oh, yellow.
And then there you go. And now we can actually go and say color 2 instead of color 1. Hit play, and we're back to black. This is because they're not storing the same value. So here I can say color 2, red is 255, and then hit play, and then I'm back to red.
So do we need to... So what is the purpose of this?
This is to create a new instance of the variable.
So we're saying color 1. So color 1 is the new variable.
It's just the name of the variable. It could be called Steve. It doesn't matter.
Is equal to new color.
Yeah. That just means you're creating a copy of this in memory somewhere. So somewhere in memory, there is a red, green, blue. There are these 3 variables. So by doing this one line here, we've actually just created 3 variables.
But it knows that red needs to take in a RGB value.
No, red needs to take in an integer.
And it knows...
It's just a value. Again, we're back to context. It's a variable. It's called red. I can do this. I can do this. Green, green, green. Because background wants 3 numbers. Here are 3 numbers. I hit play and I get black. If I do color 2 green to be some lower number, I get some sort of gray. Even though these are variables, they still need to be used in the correct context. Okay, but yeah, here's a problem. I can do this and mess it up. Wouldn't it be great if I could just give background the color and it would just know what to do with it?
Yeah,
it would be great. What they have in the language itself. So let me just do that here below. They have a type already built in called color with a small c. That's why I created color with a big C. So let's call that color 3. And since that is a built-in type, we can actually do it like this. And then let's do 255, 8t, and 50. Just some numbers. All right. I can then take this variable and just put it directly there, and then hit play.
Uh-oh. Cannot read 1 of null.
Let me see if I have it correctly in the color. Let me see. It was color C1 is equal to color. That's so color 3 is equal to, there we go. Now we should
Or some weird
orangey thing. Yeah.
Ah,
And here you pointed out a thing. You could still do the mistake. But if you have a function that knows how to handle this type, there is no mistakes. You can't do this mistake. You can do the mistake here, but you can't do it in two places at once.
So what do we do with all this color 1 stuff up above?
I'm gonna leave it for now. We're gonna do one more trick. Let's go back to color 1 red, color 1 green, and color 1 blue.
Oh, I'm a little bit behind. Let me just catch up real quick.
Or
does that matter?
You can skip color 2.
Yeah.
And then put the red, green, blue in background.
What blue?
Okay.
Yep.
So hit play on that just to make sure it's
Just
working.
white.
Good. So let's try creating a function. Let's make a function called where we can set the blue value. I know we can do it like this, but let's just try a function that does this. So it'll be void because it's not going to return anything, and let's call it set blue. And if we want to set blue, blue is of what type?
Of color.
The variable blue. What's the type of that variable?
What? It's a int.
Yeah, it's an int.
I was like int.
Yeah,
I almost said ant.
So we would like to send in another int, which blue will get that value. So we can call that new blue. Here we have a function, and what we can do is we can say blue is equal to new blue.
Now we're just telling it whatever new blue is blue now.
Yeah. So instead of this line over here, we can say, and in the same way we access blue like this, we can say set blue, but that's a function. So I can say 50. Click there, yellowish kind of color. Okay. So that was the same code being run. Blue is equal to some value. Here's a function that does it. We could create a function where we will only set the blue value if the blue value is bigger than 100. So if you try that, then we need to ask the question that's coming in. Someone wants to set a new blue value.
So it's like if. We'll do just immediately if blue.
We don't want to ask the question of blue. We want to ask the question of the new blue.
New blue is, what did we say, greater or less than?
Greater than, let's say, 100. Okay. We can put braces around that. So we only set the blue value if it is
greater than 100.
Yeah. So if we hit play here, okay. So new blue is not greater than 100.
No, because we set it to 50.
Yeah. Then it was set to white, or sorry, it was set to 0. So we get a yellow color. If I say 150,
so
a little brighter color. Yeah, let's go a little higher so people can see that difference. So here we have completely white. And then if I set it to like 5, I'll go back to yellow because it will take in the default value of 0, which it got when the thing was created. So we can do whatever code we want in here, and it will obey that law. But if we go back to this, we could imagine setting this for every single thing. Set blue, set green, set red, right? That's kind of tedious, right? And if you look at, we're lazy. I don't want to do all this work. And you see here, when I create a color, I then have to do this. But what if I forget? What if I zoom in a bit? What if someone forgets to set the blue or forgets to set?
Gonna end up with a really strange colored something.
Yeah, and that might be tricky to find out what's going on. And there's also just tedious that like, oh, I have to create a color, and every time I create a color, I have to do this red, green, blue thing afterwards. Like it's so tedious. What I want is to do that here.
Oh snap!
To just put the numbers in. Now, wouldn't that be great?
Yeah.
So what this is, it's a thing called a constructor. It is a special function, and for us, when we created the class, the language created it for us, but it was empty. It didn't do anything. But we can create our own. So let's do that. Let's erase this set blue. You did too much. I'm watching you.
Dead.
And to create the constructor, let me go back up in my notes. It is a function, but it looks a little bit weird because it has no type at the end. It doesn't say void, it doesn't say int, it doesn't say color at the end. It just says color and nothing else. And then you can open up the parentheses and start adding in the arguments. So to set the colors, we would have how many variables?
3.
Yeah. What type are they?
Ints.
Yep. What should we call them?
New blue, new. Can we call them new green, new, just new?
Yeah. We could say int new red, int new green, and int new blue. You then, you close the parentheses, and then open that scope up just like any other function. And this then acts as a function. So I can then say red is equal to new red. Green is equal to new green. And blue is shockingly equal to new blue. And if I hit play, now we're white as default, not black as default. And if I change the colors a bit to some values, whatever they are, doesn't matter, I will get some color.
I made green.
That's very Christmassy.
Oh, yeah, I didn't even do that on purpose. I just put random numbers in.
So now that's really handy to just make a new color and just say, hey, that's our color.
But how just trying to so we've taken this code.
Yeah.
And we've told it that
when you make the new object, when you say color1 is equal to new color, instead of calling some constructor, or which is basically just a function, the language is creating for us, we made it.
So then what does this line do? This is saying that color1 is equal to new color.
Yes. This is actually
this whole line I don't understand up until this point.
Okay.
I can understand that we're setting color here.
Let me try one thing.
Yeah.
This line is actually 2 lines.
Okay.
Or can be thought of as 2 lines. Let's call the color 3, just to not associate it with color 1 for a second. And I replace this down here. So we have a variable called 3. And it is of the type color. Just like int, just like Boolean, they are types. This is a type, but we made it. So color is a grouping of these 3 variables.
Yeah.
So in actuality, 3 is not 1 variable. 3 is 3 variables and this constructor. So what you can do is you can say color 3, semicolon, new line, 3 is equal to new color.
Okay. And what does new space color, what is that doing?
So this part is calling
Yeah.
this function. So that is calling this.
What's the need for new then?
It's a
just
part
to tell it to duplicate it.
It's a part of the language to say you want a copy of this class, and then to copy it, call this constructor. And I think if we go into the reference, I can search for new. Here it is. Maybe the language here explains it nicely. The description creates a new object. The keyword new is typically used similarly to the applications above, which they're doing similar things to us. In this example, a new object h1 of the data type hLine is created. So they have there's a type in the language called hLine, which is a line. So they say, here's a line called h1, and they want then a new, and then this is calling whatever constructor there is for.
So it's just saying, take this, basically.
Yeah, like this here is a constructor, make a new copy of it and put it in here.
Yeah, okay.
Yeah, so that's why I split it up, because you can create the variable, but it hasn't been initialized yet. And then you initialize it by giving it some value. So this is the value. In the same way you can do this, int car is int car, and then you can say car is equal to 40. First you made the variable, and then you gave it a value. Here we make the variable and then give it a value. But to give it a value is a little bit more complex.
Yeah, exactly. But now, so we can use the same class of color for multiple things, but still change different colors. So we're basically saying color tree. So then the new variable is tree.
Mm-hmm.
Copy the class color, which has the RGB value, and now everything that we say is tree, or everything that uses the is it class tree or the variable tree?
You can say a class tree and you can say a variable tree. That's also fine.
If whatever says tree later is taking the color you assigned to it there.
Yes.
Okay, got it.
And then you can make a new color
banana.
Banana is then a new color.
And then you gotta make it yellow.
Gotta make it yellow.
But
there you go.
And now all bananas will be yellow.
They will be yellow. And this is then another variable, which is grouping 3 other variables, the red, green, and blue, and also has the constructor function, which was then called here. And you can also do this. Some other banana is equal to banana. Because this will give you a value of type color. This also will give you a value of type color. This is also a value of type color, which we can then assign here. And I can then also create a, I can do this. Color, change color. Color, new color.
What?
Yes.
What does that even mean?
It's a function. So it's a function called change color.
Yeah.
That takes in a variable of the type color.
Yeah.
And returns color. Let's try that.
Okay.
So we have a variable coming in here. It's called new color. Okay, let's say that we double every value that is in color and then return that. So whatever we give it, it doubles the value. Sounds good? So to do this, there are 2 ways. One is like an optimized way to do it. I don't want to do that. I want to do the very straightforward way to do this. So I want to create a variable called color. That's of the type color, which is, we can call it changed color, which is new color. So we send in a color and I copy it. And then I'm going to say changed color red is equal to changed color red times 2.
Why is this not even?
Yeah, it looks bigger on my end because I have it zoomed in.
No, I meant I had like it was like here.
Oh, okay, sure. And I can copy this 3 times. One for its color, red, green. Whoops, copy the whole line. And then blue. So this is kind of a terse way to do this, but I wanted to show a point. So the function is just called change color. That's just the name of it. It will return a value of type color. So anything that returns from the function has to be of type color. And it takes in a variable of type color. We create a new variable inside the function called the changed color, which initially takes the variable coming in, and then we take each value and double it. The red inside of change color is the red inside of change color times 2. Same thing for the green, same thing for the blue. But there's one line missing, which is then return changed color. So we have a function, we call it, we give it a value, we do some work, and when that work is done, we can return the changed color. So if we delete these things here, so we only have the tree, let's give it a low value, maybe 55. That might be noticeable enough. Okay, if I hit play, I will still get the gray that we had before. Oops.
Oh, color 1 is not defined.
It might be still called color 1 in your background. If you scroll down more.
Oh, yeah.
Yeah. So rename that to tree.
Oh, yeah, tree.
And I call it tree just to emphasize that the names don't matter. They're just for us. There we go. So I call setup, but before we call background, let's call the function that we made. And the function is called change color. So, and it returns a variable of type color. So I need to create a variable called color first, because we need to store it. And then we can call that new tree, if you want, is equal to change color tree. So do you see what's happening now? Initially, we created a variable called tree. It was created up here. It's storing 3 values, red, green, and blue. Down here, we create a variable called new tree, which is the result of the function change color, which is here, taking the color in, doubling the value, and then returning it. And the new color that we send in is tree, which we created before. So then if we say new tree here below in the setup function. So instead of tree, you have new tree. We should see a little lighter gray. Oops. What did it say?
Where do I keep messing it up? Unexpected identifier.
Let's go through this. So let's look at the change color function. Color, new color. Color, change color. Wondering if there's a spelling error somewhere there.
Yeah, most likely.
Unexpected identifier. Not seeing it. Let me see. It's in those lines, definitely. So the function is called change color. Change. The variable coming in is called new color. Changed color. There it is. It was hiding. There it is. So if you have yours, hit play on that. And I will use the old one. Wait. It doesn't.
These colors are vastly different from what's on that screen and what's on my screen.
Okay, so the contrasting is weird. Okay. Anyway, so if I we can keep that as this. So we have the class we have a new type of function called a constructor, which is only called when you make a new version of the type. We can create a variable of that type. We have to say new to create a new copy of it, and then we can call the constructor. We can then start to use it just like any other type. And in the same way, we can modify it and give it to. So there's nothing different about the way we're using these variables. We just have to access them in a different way. And what we've created is an abstraction. So color is in fact an abstraction of 3 variables. Because before we would have to do this, int red, int green, int blue, to be able to create to change these values. But now we can just say, here's the new color.
Asd
is a great color. So it wraps it around into a nice little package, and that's very, very useful. Very useful. All right. So that is, for us, episode 4.
Sweet. That was interesting.
I hope you learned something.
I asked a lot of questions.
We have a lot of questions. Can you shoot one now before we end?
What even is this?
Magic. And a big thing about this is getting used to it. It's a lot of new concepts, and regarding getting used to things, it just takes time to sit down and then do it again and do it again and do it again. Like, there's a big jump in going from this is just a number to what even is this?
Yeah.
But if you think of it as it's just a grouping of 3 numbers, then that can help a lot. In this language, things are copied pretty extensively, or I think they're even not even copied, they're referenced, which might be the reason why the color didn't change that much. So we might actually have changed the external color. But the language helps you in moving those variables between. So when you say color and you just give it a color, you might think, but how is it able to just send in 3 variables like magic in one variable? But the language handles that for you. So you don't have to think about that. You can just say,
Smart.
I just want to send it in color.
Just want colors.
Yeah, just give me the colors. There's still like cases where you can mess up, like we could have mixed this up here. But it definitely helps us create abstractions around an idea. And in this case, color is definitely an idea. We have, look how we're using it. We're assigning it to a color in the world. But from the computer's perspective, it's just 3 variables. It's just 3 numbers. It has no idea that for us, this is a color, because it does not read and understand this name, and the same thing with these names. So for the language, it's just a grouping of 3 numbers, but we give it context, and that's important. Sweet.
Nice. See? Episode 4. It's a wrap.
It's a wrap.
So
like a.
So everything will be down in the description below.
Yes.
Code, the tool, everything that we're using.
Correct.
Episode 5
coming soon.
Yeah, next week. There won't be a stream on Friday, the week that this gets published, so this will go up on Monday, which is the day that this is maybe when you're watching this. Now I'm just confusing myself. But there won't be a stream on Friday the 16th.
Yes.
But we still will have
an episode.
Episode 5 will be on Monday in a week from when this video is published, so on the 19th.
And then there will be a stream on the 23rd.
Yes.
But there won't be a stream on the 30th.
Yes, which might be our little 1 week break at some point. We'll figure it out. But either way, this is episode 4. Episode 5 will be out in a week.
Bye.
Bye.